Hi, good day. Welcome to my presentation on Open Glider Network and Flarm. As Lawrence says, you've always got to have a who am I slide. So I've been gliding for a few years now. Professionally, I am a software engineer and have been in that industry for 15 years or so. And now I'm consulting to the telecommunications, computer vision, and Internet of Things industries. So the objectives of this presentation are to clarify what a Flarm device is, what the Open Glider Network is, and how can OGN help you, the glider pilot, and indeed all general aviation pilots. First, a little segue to e-conspicuity, because that is becoming a more and more of a buzzword as UAVs and drones and the general airspaces become more and more congested. E-conspicuity has become to be known as a device that transmits its identity and position, generally publicly so others can receive it. It doesn't necessarily imply that that device can receive others' positions or detect imminent collisions or even display information or have any alerting or anything like that. There are many e-conspicuity devices around at the moment, and those are vary in costs from very cheap DIY things to, even ADSB out. It's Flarm's DIY OGN trackers, pilot aware spot, Fanet for the paragliders, spider tracks, and so on. To continue the segue, I find it useful in my head to think of the different levels, or at least to classify these devices into different levels, how in terms of their capabilities. So for instance, at the very, very basic level, we've got a device which can transmit position and sometimes velocity and acceleration, like ADSB out, all these conspicuity devices, Flarms, and so on. And similarly, some of those devices can receive other telemetry and display on a moving map or something like that where others are. The next step up is to calculate the collision risk and visually or orally alert when another aircraft gets within a sort of intrusion zone. That requires a little bit of forecasting, and you've got to decide which of the targets you're going to track. Imagine an extremely popular day in Europe, and you may be receiving hundreds of gliders, Flarms positions. The device has to decide which of those is it actually. It doesn't have time to calculate where all of them are going to be in the next 30 seconds. It needs to have an algorithm to work out which ones of those are even worth tracking. Number 3 on the list is, if there is a collision risk, then determine a resolution advisory. This is not my area of expertise, but suffice to say, it's devices which can do this are a lot more expensive than our walk-on devices like Flarms. Level 4 is probably automatically fly that resolution like drones in the future will have to be able to do, and possibly fighter jets or autopilots. Right, back to what is a Flarm device. I'm sure most of you have seen these Flarm devices sitting on your glider or on club gliders. It's a device which transmits its identity, position, velocity, and turn rate, amongst other things, receives other aircraft's similar transmissions, so that gets their telemetry, and then determines if there's an imminent collision risk. And if so, it displays the closest or the most dangerous intruders and targets, and then it's up to the pilot to manually resolve this situation. So Flarm is a portmanteau of flight and alarm, and it gets its position from an internal commercial off-the-shelf GPS. It's important to note that maybe a Flarm from 2006 or 2009 or something has just got a commercial off-the-shelf cell phone grade GPS in it. So if one can imagine or remember back to how long it took cell phones to get a GPS lock, acquire a lock back in 2006, one has some idea of the amount of warm-up time it takes for some of these older devices to start to get a GPS lock and therefore be able to start transmitting their accurate position or their position accurately, and therefore start providing the safety capabilities advertised on the tin. A Flarm generally also contains a barometric pressure sensor. It is not transmitted and it's not used in the collision report or the collision algorithm calculations, but it is logged in the often built-in IGC logger. So this is what Flarm says themselves. Flarm is the traffic awareness and collision avoidance technology for general aviation, light aircraft, and UAVs. And it basically broadcasts its GPS position to all other Flarm-equipped aircraft. These flight paths approximate aircraft are then compared. When an imminent collision is detected, an oral or visual warning is issued together with the relative bearing and altitude difference of those intruders. You can see on this one on the right here, the new Flarms will show two different intruders. And obviously the one on the left, the red, is the closer one. 22 is the distance, I think it's the distance in tens of meters, so it would be 220 meters, I think. See the Flarm manual for the actual details. This is quite a technical slide. Ignore it if you're not technically inclined. Basically, the Flarm transmits on the Industrial Scientific and Measurement Band in South Africa, which is 868 megahertz. There's a 1% duty cycle, so a lot of Flarms can transmit without stepping on each other's toes, although because it's a shared medium, there is a chance that they don't listen and they don't all specifically transmit at different times to not step on each other's toes, so they might. But by including a random timeout, one can often receive, even if Flarms A and B step on each other's toes in 1 second, the next transmission, because it includes a random waiting period, won't step on each other's toes most likely. Transmits at about 25 milliwatts, which can be picked up by OGN receivers at a huge distance compared to the Flarm device itself, which the new ones can receive over 10 kilometers. The Flarm radio protocol is encrypted, unlike ADSB and OGN. So, got to ask, are they creating monopoly or are they adding to the safety of the system? Flarm is also a certified, most of the devices are certified, so that's important with type certified aircraft. A decrypted Flarm radio packet example is shown below here. It's very technical, but I'll just briefly go through it. I may get some of it wrong, so feel free to comment if I've messed it up. I think this is the second offset from the start of the second that it transmits at. The actual frequency that is received by the receiver, the ID, this is our motor folk at Cape Gliding Club, the number of packets that this receiver has received from this device, and here we have latitude and longitude in GPS, coordinate reference system, altitude, vertical velocity, heading, turn rate. I may be getting things wrong now. GPS status, I think 0 is no lock, 2 is 2D lock, 0 is no lock, 1 is 2D lock, 2 is 3D lock, and so on. The offset in frequency, the number of errors that have been decoded in the packet and have been corrected, hopefully corrected for with the, I think it's a forward error correction protocol, and signal strength, and so on. So there's a lot of information in one single Flarm packet. It's not just an altitude or just an identity and a GPS location and an altitude. There are really velocities, accelerations, and statuses which allow one, the receiver, to work out the integrity or confidence of that packet, like how many GPSs, how many satellites it can see, the GPS status lock, the dilution of precision, and the amount of errors that have been received by the receiver. That basically explains Flarm. There's not a hell of a lot more to it. Let's move on now to the OpenGlider network. I'll just paraphrase from their website. The objective of the OpenGlider network is to create and maintain a unified tracking platform for gliders, drones, and other aircraft. Focused on tracking aircraft equipped with Flarm and OGN trackers, OGN is also open for integrating of other data sources, such as PilotAware, Spot, Garmin InReach, SkyMaster, FANET, and SpiderTracks. The key components of OGN are the ground receivers that forward this e-conspicuity traffic, like the aforementioned devices. They forward that to the APRS servers, who curate, collate, and forward that data onto the websites and applications that use it. Then separately, there's a device database of the aircraft details, like registrations and types. I'll now go through these, except for the servers, in more detail. Now, one thing about the servers is you can imagine you've got a whole bunch of OGN receivers. Let's go to the next slide. Let's follow the path of a Flarm packet from this glider up here. So this glider transmits its packet. It's received by, say, a tow plane, and the tow plane's Flarm device. That constitutes the normal operation of Flarm. The tow plane will get an alert, and vice versa, actually symmetrically vice versa, whether we'll get an alert when the glider is going to encroach on its expected position in 30 seconds time. So that's the normal operation of Flarm. The pilots can then mutually observe each other and take corrective action. That Flarm packet that's transmitted from this glider also gets received by a couple of OGN receivers, OpenGlider network receivers. Those packets get forwarded over the standard internet to the OGN servers. Those servers then have the job of curating those packets. So you can imagine it's a duplicate packet. That same one packet has been received twice. So those servers have to deduplicate that packet. This glider may also be transmitting those packets very, very often, because it's not always Flarm. There's many other protocols which can be received, which I've already mentioned. And those packets then may need to be throttled a bit, so that we only get a position update per aircraft every second or 2 seconds. We don't want 10 per second coming through, because it's going to overwhelm the downstream servers, the downstream applications. Then these downstream applications and websites can simply subscribe to these servers. Well, they can subscribe to get information from these servers. That information can be the positions of the gliders, which is the obvious one. It can also be the statuses of the receivers. Let's not go into that though. The method of subscription is you either subscribe to the entire globe and you get all the traffic for the entire world, or you give your position or a position of interest and a radius, and then the APRS server will only forward those packets which are of interest to you in terms of your geographic location. So for instance, you might choose Bloemfontein and a radius of 700 kilometers, and then you'll most probably receive all the OGN APRS information for South Africa. Volunteers at glider clubs and at home and on top of mountains and at their schools and so on run these ground receivers all over the world. The green ones are the ones which are currently working this week, and the red ones are the ones which are registered but aren't actually switched on. So you can see in South Africa we've got a number in the Cape, and then I think this live one is in Ottosdal. As you can see, Europe is heavily populated with this. Here's an example on the right of what they look like. It's not this small antenna, it's this big 9 dBi antenna on the left here, and inside here, I'll show you in the next slide. You can see at the bottom there's one little cable which gives it power and internet connectivity, and it's just put in some drain pipe, and lo and behold, it's been running for 3 or 4 years at Worcester. This is an example of the inside of one of those, well, one of the older ones that I built. A Raspberry Pi running an OGN software. This OGN software does include a binary blob from Flarm to allow us to decode the encrypted Flarm packets. So it's not specifically open source, but by providing that, we can then decode the Flarm packets. Then there's a software-defined radio. This one has a built-in low noise amplifier to amplify the signal as much as possible without introducing too much noise. And then the antenna plugs straight into here, so it minimizes the path losses between the antenna and the receiver to try and get the highest fidelity of signal, the highest signal to noise ratio. This is just a power over Ethernet power supply, don't worry about that. Yeah, so it's important to note that these are just run by volunteers. They've been bought by gliding clubs or individuals and installed all around the world to provide this useful service by people like you and me. There's no sort of master control, like for example, Flight Aware, which is a commercial company which provide these software-defined radios actually to receive ADS-B 1090 megahertz airline traffic, well, commercial traffic. Okay, the device database. So the Ogn Device Database is a database which simply links Flarm IDs to plane registrations. So it just allows a lot of useful information to be associated with a Flarm ID. If one registers one's Flarm on the device database, which all Flarm owners should do, please. These are the purported advantages. You can influence how your glide is displayed on the tracking sites. So that's say competition numbers, registrations, whether you want anonymous tracking or no tracking at all. In the case of search and rescue, your glider may be easier to find, and you contribute to traffic awareness among other pilots and air traffic control. The device database is the component that Boris, the IGC scorer, is always trying to curate before gliding competitions commence, so that we don't end up with all these unknown anonymous gliders flying around. We know where they are, when they landed, when they took off, and who's who. This is the link to go to register your Flarm device. You basically get presented with a page like this, where you put in your Flarm ID, your aircraft type, registration, and competition number. You can then decide not to be tracked, or if you want to be tracked anonymously. But in general, leave it untracked unless you have a reason not to. The devices database has 21,000 or so registered devices, and you can download that and search them. For instance, you may want to find all the gliders registered with ZS registrations. It's a very simple query to do. There's also a separate FlarmNet device database. I've never really used it. I don't know many other applications which do use it, so no real need to do that. The device database, and indeed all the data in Ogn, is governed by the following license conditions. I know this is boring legalese stuff, but some consequences do follow from this. So the data is licensed under the Open Database license, but has the following additional rules added. You must follow the device's database tracking privacy choices. So that means, as I chatted about earlier, if somebody clicks their plane as anonymous, then you must not show the registration details on your app or website. And you're not allowed to redistribute ODN data that is older than 24 hours. So there've been a lot of debates about the privacy of OGN, and with GDPR coming in, or already in, this rule was decided on. And this is why, I mean, a few times people have come to me and said, Colin, please can you just give me the track of that plane from yesterday when that crazy incident happened? Unless it's a safety of life situation, that data is not available for privacy reasons. You can't get the track of a plane which flew 2 weeks ago to compare it with airspace restrictions or something like that. So just important to know, it's not a technical limitation, it's a legal limitation, which you are bound by when getting all these position reports from Ogn, like I mentioned earlier. Right, so the Ogn component of the websites and applications, this is the crux of all. This is where all the useful information is. This is the point of Ogn from our end user perspective. This is the reason for Ogn's existence. So an website or application will connect to Ogn. It'll receive a stream of aircraft positions and receive station statuses and so on. And as mentioned before, when you subscribe to that, you can subscribe to only a local area or the entire globe. There are many types of applications that have been built on top of the Ogn data. The obvious one is tracking aircraft on a moving map in real time. Another example would be logging flights automatically. So that's turning all these millions of position reports into a flight, grouping them all together, maybe linking them to a tow plane or a winch and or an airport. Flarm, device monitoring and installation. So I know we had this incident at the competition, the Western Cape Gauntlet, where brand new Flarm installed in a brand new glider and nobody could see them. So yeah, we'll talk more about that. Receiver monitoring. So this is the Ogn receivers. You want to know what your range is. Are there any blind spots? Situational awareness applications. Which glider is next to launch? What height did the last winch launch achieve? Air situational awareness. The Ogn feeds can be piped straight into gliding computers like XE-SAW to show nearby targets. Search and rescue, which is basically a specialization of the tracking above. Now, as I said, the tracking, there are many websites. There's an application, Android application called Ogn Viewer, which is very useful. Spot the gliders is the default one. Flight Radar, as you can see, also gets its information from Open Glider Network for gliders. Yeah, there are many of those. Feel free to click on the links when you get this presentation later. Here's an example of Spot the Gliders website. These are the gliders on this week in Southern United Kingdom. Lots of gliders. I think this was a weekday. Lots of gliders. This is a barograph of on the left of them, of all their flights. I think I left this running for 10 minutes or so. You can see even RAF helicopters, Eurocopters, are sporting Flarms and is that a Flarm? Yes, the device ID DD is a Flarm, and transmitting their positions. Tow planes, gliders, hot air balloons, helicopters, microlights, and so on. These the ones where you see registrations are registered in the device database. The ones with the _7E or the _B8, those are devices which need to be added to the device database. So this is how your plane appears when you have a Flarm, but you haven't put it yet in the device database, and nobody knows which type of plane or what registration or competition number we're using. Here's another application which shows the popular areas where we fly in Worcester. Of course, this presupposes the receiver station's coverage map. But within the coverage map, you can see the popular places where we fly as a heat map. My personal most useful OGN application is automatic flight logging, collecting the aircraft's individual position reports into a flight and linking them to gliders, linking gliders to tow planes or to winch launchers and to an airport. My Gliding Club automatically retrieves these flight logs from the KTrax logbook API, which is one of the services which provides flight logging. This is a paid-for service, but very useful. I mean, we can take an example of here. Uniform Charlie was towed by Zulu Golf, our tow plane. The release height was, well, we don't know the release height, but we can guess it was around about 2,460 feet above ground. Tow time, 8 minutes. Uniform Charlie's total flight duration, 3 hours 30. Very useful, especially when it automatically fills one's club's gliding timesheet in. So this use case is device monitoring. And by device, I mean the Flarm installed in your airplane. You go to all the effort of buying it, installing it. The lights are flashing, the GPS is locked, the transmit lights flashing, the receive lights flashing. You can see other planes. But how do you know that those other planes can see you? It's a tricky problem to solve. So you just browse over to, in this case, the free KTrax range analyzer with your Flarm ID, and you get these 2 charts, plus a whole lot of other extra information. These charts tell you the average Flarm's signal strength, this green line, by distance. So here we've got 5,000 meters, 10 kilometers, 15 kilometers. They show how the signal strength decays over distance. And then you can see your specific Flarm's performance, which if it is significantly below average, then one might think the installation needs to be redone or antennas need to be positioned differently and that type of thing. The chart on the left shows the same thing in a plan view. That's a plan view of the plane, and you can see the relative signal strengths. This is the 10 dB line here, I think, and the 10 to 20 dB line here. That's the relative signal strength. So, for instance, if there was another instrument with metal in it blocking your Flarm from transmitting only in one direction, for instance, over the left wing, then one would see a Pac-Man type shape with a bite taken out of it on the left here. And then you'd know, okay, I've got to go and change my airplane's Flarm installation. It's also useful as a Gliding Club, for instance, to check which version of software you're running and even do an audit on the actual hardware, so how old the hardware is in the various planes. I mean, you may have, yeah. You don't want to have your tug plane, which is doing the most flights and costing the most to run, with the oldest Flarms, which take 15 minutes to get a GPS lock on it, for example. You can sit in your armchair and you can browse your club's fleet, and you can already do an audit on what sort of situation your Flarms are in. So very useful device monitoring. Receiver monitoring is the monitoring of the actual receiver base stations themselves. It's not really of interest to everybody, but if you have built a base station, you do want to monitor various things on it. Those status messages are broadcast by the Ogn network, and those are then people have written applications which collect that data and present pretty charts about it. For example, this is how much noise we're getting from the external environment at Worcester, CPU load of our Raspberry Pi, the temperature. And you can see when there's load shedding, because obviously the temperature goes down. It's a critical chart to look at during summer where the outside temperature is 40 plus. You can imagine things start throttling at around 70 or so degrees. Yeah, lots of stats. What versions you're running, how many aircraft can you see, how far out is your clock, what's the latency of your internet, and so on and so on. When you plot that data on a chart, well, this shows the range of our receivers. So I think this is not an individual one. This is all of them put together. So these are the position buckets that we in the Western Cape have received Flarm position reports from. So that's very useful to check which receivers and the network as a whole, from where can one expect position reports. There's also a lot of settings on this. You can, for example, give the minimum height. When flying out to sea and wave, you'll find the minimum height that we've ever received positions from is very high, but that's because they've got to get over these mountains as well. So yeah, I mean, there's a lot of information one can get. I'll show you a picture of the range or traces received from upcountry, so you can see Bloemfontein and so on. These are the gliding tracks which are currently in the system. It's a lot easier to receive packets from further away upcountry in the flatter landscape. So one could get away with far less OGN receivers, as long as they are not positioned too deep in the valley, to enable glider tracking over the whole of the central area, the Highveld. Obviously, if one wants to track flight logs, one wants automatic flight log creation, then one needs a OGN receiver at the airport. Can't afford to have a OGN receiver far away, losing sight of an airplane as it's coming down to land, because it's now hidden by the hangars, for example, at that exact airport, or the slope of the runway going beyond line of sight. And that basically concludes my presentation. Feel free to ask any questions. This is a picture of all the gliders on the grid at the Western Cape Gauntlet. And just for completeness sake, the only other slide I've got here is just an example of how to receive Flarm targets on your XE-SAW from OGN. You run OGN Viewer, you enable the web server, set up the connection to the web server from XE-SAW, and voila, you'll be receiving Flarm targets. But yes, thank you very much for your time. Hope you enjoyed it. Have a good evening. I think the questions can be asked on this YouTube channel.